I'm Alex from Anodot, and we are providing basically a cloud cost monitoring and optimization solution. Imagine you have some dashboard monitoring all your cloud spending and some meaningful insights on top of it, and actionable recommendations you can apply to your environment in a few clicks. So this is the product, and let's take a look on a few screenshots. So for example, this is the main dashboard of the system, and you can see a lot of numbers here, and basically each number here is some product choice. So should we display the month-to-date cost, or year-to-date, or daily cost, and forecast for the next month or 3 months, and so on. Just in our screen, anomaly detection, so we're detecting anomalies, found root cause for each anomaly, like what is the responsible team and the product, environment, so on and so on. We just can't display all the information on the same screen. And this is our main analytical screen, which is Cost and Usage Explorer. And you can see a lot of predefined filters and aggregations, but our customers coming with some unique and complex questions we just can't always answer with predefined report, right? So about a year ago, we turned to Text-2-SQL technology, and to be able to answer as many ad hoc questions as possible. So here I will start the story. So for example, I'm asking the system about most significant cost increase during like previous month. And first of all, let's take a look on the output here. So we are reflecting the question to the customer and trying to explain the execution plan of the query. It's important for the questions we can answer, but it's even more important for the questions we can't answer. To distinguish actually between like no data or missing data and some logical error or bug in code. The second section is the data itself, like tabular data, and the last one is the visualization, also generated using LLM. Like basically all the sections here are generated using LLM, and I will talk about it in a few slides. So I found actually some increase in EC2 service, and I want to drill down into instance type. So I'm looking what's actually the most expensive instance or the most used instance here, and I have a winner, like 60–70% of all my workload is associated with this specific instance type, which is R6G, and I want to drill down and look for forecasts this year, and okay, I see I have a problem. So previous month it was like additional $8,000, and it will increase. Or on at this point, probably as FinOps, I will understand, okay, I know who is the team using this instance type or which product uses this workload and so on. I'm not FinOps, so I just did by region breakdown. And I see actually, okay, the green one is fine, the blue one is fine as well, and I have a problem with the US East one, which is the problematic region, and I need to understand what's going on. So just to show we can create some meaningful insight just in a few minutes or like follow-up questions. In the system, we want to be able to answer retrospective analysis questions, forecasts with predictive analysis, and more. On high level, it looks like this. So we have a user question with a classification agent. The classification agent is actually responsible to assign a proper agent for each type of question. So we have agent for retrospective analysis, agent for forecasting, and so on. It will receive all the relevant context for this specific type of question and this specific type of agent. As output, we will have the explanation, visualization, and build answer. All right. Just before I'm starting with the challenges, I want to talk about the data and the evaluation of the results, because we started like a year and a half ago without any actual data we can use, with no actual like synthetical data set, good synthetical data set we can use. So we generated our own from about 100 questions from customer success and product teams, and generated more using LLMs. But today we have a good synthetic data sets like this one, for example, which is Gretel AI with a lot of different types of questions like subqueries, multi-joins, CTEs, window functions, and so on. As well, I just adding here the survey article about LLM for LLM-based text-to-SQL. And about the evaluation. So, okay, we have some ground truth data set, but how can we compare the query generated by LLM to ground truth? And the exact match not really works, as you understand. Like even if you're changing some alias of the column, something like that, it's not the same query anymore. A little better similarity with LLM works. So you can ask in our LLM to evaluate the results against the original query. It can be poisoned by hallucinations from the first one. And currently we are creating some framework for like decomposition of SQL query to the components and evaluating each component separately. So we can evaluate source table, columns, filters, aggregations, and so on. And we actually can give a different weight for each component. So obviously like table is super important, the filter is super important. But maybe number of aggregations is less important because you are still providing all the data, right? So yeah, okay, I will start with the challenges. Okay, so the context is super important. We are providing a lot of context to the model. Obviously, we are providing task definition and some impersonation, like you are very smart FinOps analyst, building query for this question, and so on, and some domain knowledge, or for example, if I prefer amortized cost over unblended cost, or if I want to exclude all the taxes, or prefer data without taxes first, things like that. This one is more trickier, so we need to provide our database structure somehow to the LLM. And the naive approach, just schema discovery and push all the schema to LLM, not really works well. Like, okay, I will explain. So we are actually using some abstract schema on top of the original database schema, and it solves a few things. Like first of all, you don't need to provide all the columns and tables in your database, so you are reducing the number of hallucinations significantly. Okay, like extreme example, like think about one table and 5 columns, probably 0 hallucinations. Also it gives like some like superpower to reuse the queries across different users. So basically we're applying all the filters and like row level security or any other security rules you have in the system under the hood, okay, not using LLM. So basically I can use the same query generated by LLM for any user in the system and it still works, which is fine. And of course, we need to provide some table content, like what's the values in each column and column. I will just mention like methods without drilling down. So you can use some random sampling from the columns, or you can use like most common calculated ahead of time, or for example, the most representative values for each column, which is a little more tricky. And of course, syntax examples. So we understand, like, I mean, like data trunk function not works the same way in Redshift, BigQuery, and Postgres. So you need to provide some information about it and some examples of historical queries. And as we all know, like vector database with embedding, so we are creating taking our ground truth, creating embedding for all the historical questions, like looking for the 5 most similar to the question user asking currently. The problem with this approach is basically if we have a lot of similar questions in our database, think about it, like what is the EC2 cost last month, what is EC2 cost previous month, what was EC2 cost 2 months ago. So we're providing a lot of examples, but almost 0 additional information for each next example you're providing. It's not about improving results, it's more about like wasting your tokens. What you can do, you can create clusters on top of your ground truth. Okay, like basically any arbitrary number of clusters. And instead of looking for the 5 most similar questions, you are looking for 5 most similar centroids and sampling 1 question from each cluster. Like this way you're providing like richer context for your LLM model. And of course you can reuse the examples if you have like very high similarity between the question user is asking and the one you have in the ground truth, you can just reuse this answer as is, like with 5 nines or something like that. in our problem with embeddings is not all the context we want to provide to the model is embeddable. Okay, so for example, for S3, I want to provide all the storage types. Or for all the ARM questions, I want to provide some Graviton specs or some information about Graviton instances. So we are using some hybrid approach between like embeddings and token similarity here. Another like nice trick, assuming you have 95% accuracy for all your generated queries, which is still not enough. Like basically it means in every 20 answers you will have at least one error, right? To improve it a little, you can generate multiple answers all the time. So we are generating like 3 answers for each question. I'm just trying the first one. If it not works, trying the second one. If it not works, trying the third one, and so on. You have a little like difference between 3 requests with single answer. Like I can run simultaneously 3 requests with a single answer, or 1 request with 3 answers, like n of 3. And with n of 3, I'm actually getting more variance. Like from my experiments, like 90% of the cases, I have at least 2 different queries. With n of 1, most of the time you're getting the same query. Like probably because of the caching of base model. And as bonus, you're actually creating some data set of possible answers. Okay, if some, like at least 2 good answers in the data set, you will increasing your good answers data set. Structured output, like obviously we want all the communication between agents in the system to be structured somehow. And again, like functions, tools. This example is for visualization generation. So we don't want to run the generated code in our system, but we want to LLM to choose the best visualization method for this specific question, give us the title of the visualization, and provide what is X and what is Y, so I can just plug and play parameters in our visualization code and generate the plot. You have a few links here. Yeah, in our trick, so we did like a month ago, we did some work with Automated to migrate the classification agent to AWS Bedrock, and actually found it works faster in some cases. So assuming you have some fast, like small and fast model and slower and expensive one, sometimes you want to run the small one, evaluate the results, and if the results are good enough, you are using the response. If not, you are using the slower model, but you will need the evaluator. Like, how can you evaluate the results of the classification? And this is the nice stuff. Actually, you can use probabilities from the LM model itself. In case of classification, I can limit the output to the single token, like max tokens of 1. And assuming I'm asking something like, is this question related to AWS? Return 1 if yes, 0 if no, and limiting the output to 1 token, and but asking for log probabilities for the 10 most probable. Okay, so I'm getting something like this, like 91% for 1, 9% for 0, and saying, okay, the model is confident enough, I can use this answer, like, looks good. The same case, I'm getting like 25, 20, and some long tail of distribution. I'm just ignoring it and using slower modeling. To improve the speed, somehow basically caching everything. So we are caching the data itself for specific user. We are caching the answers, actually queries, across all the users in the system. So we can use the same query in the different users as we discussed on the first slide. And of course, using some similar queries we found in the system as examples for the user. Okay, about the feedbacks. So negative feedback loop, basically we want to remove anything related to this question from the system. So the next time the same user or any other user asks the same question, we want to regenerate the result, and maybe this time it will be better. For positive feedback, the opposite, we want to save the result and use it as part of our ground truth for examples we are providing, right? So currently we are working on evaluating our AWS Bedrock in our agents. We want to support like more complex flows, like follow-up questions and some more interesting interaction in our system. Also to save and recheck, for example, so you can like dynamically generate the report and reuse it or send it every Monday or something like that. And of course, like better MSP support. So, for example, if you are running your own customers on top of AWS, you can ask what was the cost for each of my customers and get some like interesting report about it. Yeah. So I provided some bag of tips and tricks, and if you are solving a similar problem, probably you will find it useful. At least some of those. Yeah.
Repeat the question.
Okay. Mm-hmm. Yeah, true. So basically, we are not. Sorry. How to evaluate the answer of LLM for text-to-SQL generation? You can base your evaluation on feedback the user is giving you, or you can again keep your ground truth and actually check it against it. Like there is no way you can detect the query is wrong, like except SQL exception or error. To detect it's wrong, like in the runtime, right? Yeah. Yeah.
What are the conditions that you disqualify the cache table? Meaning that the data fields are changing?
How to invalidate the cache, like data cache. Yeah, I'm repeating. How to invalidate the data cache in the system. Like basically we are not a real-time system. We are updating our data like multiple times a day. So I know like the case we have a new data and they will need to regenerate it. The query itself will be almost the same all over time.
Looking for similar questions, right? If it was already the query similar, so you do not generate a new response from the LLM.
True. Yes.
If the data table fields change.
Okay. So you're talking about like schema change and evaluation. Again, I'm not running on a real database schema, right? I'm running on my imaginary schema. I'm like managing, so I can understand, okay, it was some change. I just need to invalidate all the queries I have in the like ground truth database related to this field. Or update it, by the way.
Thank you.